Hello everyone, this MATLAB project implements the Salp swarm algorithm which is developed by the Syed Ali Miraj Ali and his team. The algorithm is designed to solve engineering optimization problems by mimicking the behavior of the Salps. The project includes several MATLAB files function files that work together to define the benchmark functions, initialize the population of the Salps, and execute the optimization process. The main goal of this project is to optimize a given objective function defined in this get functions details dot m file, which you can see right over here. So let's start with the initialization.m file. So this file initializes the position of the salps, which are actually the search agents within the defined search space. The search space actually is bound by the LB lower bounds and the upper bounds, which are provided based on the selected benchmark function. The position of the salps are randomly generated within these bounds using the formula, and here you can see the program include the random process. So this ensures that the initial population is spread across the search space, allowing the algorithm to explore different regions. And now let's go through the function plot.m file. So here is the function plot m file. So now here is the function underscore plot dot m file. This file is responsible for visualizing the benchmark function in 3D space. It generates a mesh grid for a given function and plot the surface using srfc function. This function helps in understanding the shape and complexity of the benchmark function, which can be useful for analyzing the optimization process. And next there is a get function underscore details dot m file. This file contains the definition of 23 benchmark functions from f1 to f23 that are commonly used to test optimization algorithm. So each function has a specific lower bound LB and the upper bound UB and the dimension which is represented by DIM. So the file returns the objective function handle FOBJ and which is used to evaluate the fitness of the salps. So let's start with this function f1. This function calculates the sum of the squares of the input vector x, which is a common test function for optimization algorithm. So similarly, there are all the functions. Everyone is have different nature, and different calculations is assigned to each function. And next let's move into ssa.m file, which is actually the main file. And in this file, so initially we have initialization part where we just are initializing and creating the variables for these salps. And then there is a section for fitness evaluation. The fitness of each salp is calculated using the objective function FOBJ. And then the next part includes the sorting. The salps are sorted. So here the salps are sorted based on their fitness values, and the best solution food position is identified. So this is the main loop. The algorithm iteratively updates the position of these salps. And here is a leader salp. Let me show you that. So this equation represent the leader salp. The first half of the salp's leader move towards the food position using this equation. And here the C1, this one, here C1 is a coefficient that decreases over time, and C2 and C2 are the random numbers. Here the next one is Folver. Next one is the Folver Salp. So the remaining Salp followers update their position based on the average of their current position and the position of the Salp in front of them.